So before we start talking about quadratics, I want to take a look again at the distributive property because it's going to be really important for us learning how to factor quadratics. So we're already pretty familiar with how to simplify something like this. We can take the number out of the front of the parentheses and multiply it through each term. So in this case, we'd get 3 times x plus 3 times 5, which is 15. Now, we can actually do distribution on a larger scale. So hopefully you've seen this before, but we can also do distribution when we have two binomials, which means we've got two terms times two other terms. So the way this distribution works is pretty similar. We take the first term and distribute it through. So it's going to get multiplied times everything. We get x squared, because x times x. We get x times 5, which would be 5x. And then we also need to distribute the second term. We take this 3, and we're going to distribute that as well. We get 3 times x, and we get 3 times 5. All together, when we write the final answer here, we got x squared plus 5x and 3x make 8x. Find some like terms, plus 15. You'll notice what we end up with here is a quadratic in standard form, which is what we're about to talk about. So as we practice factoring this, we're going to be doing this process backwards. Here we have a quadratic. When we say quadratic, we mean a function with a squared term. That x squared is basically the term that's going to be in charge because it's going to grow or shrink faster than anything else. So this is our quadratic equation. We call it a quadratic because of that squared, that x squared. All right, so when we say we want to solve a quadratic, what we mean is we want to figure out where the function hits the x-axis. So if I take a look at this function in Desmos real quick, there are two solutions to this graph. Again, our goal is to figure out what the x-intercepts are. Since we've been talking about systems, we can think about it as where does this function equal 0? In other words, where does it touch the line y equals 0? Again, that happens in two places on this graph, at -3 and at -4. Let's see if we can figure out those same solutions algebraically. Again, our goal is to solve the quadratic, which means to find where it is equal to 0, or where it touches the y-axis, or x-axis, sorry. Okay, so we can look at a step-by-step for this, and I'll kind of walk you through this, but then we're going to look at an example or two, which will help kind of understand the process. So the first thing we want to make sure we always do is make sure that our function is written in standard form. This is what standard form looks like. Ax squared plus bx plus c equals 0. So standard form means we have the x squared bit out front, followed by the x term, followed by the constant term, just the plain number. All right, and we notice that it's set equal to 0 because we're trying to figure out when is y equal to 0. All right. After that, we want to find the factors of c, we'll talk about that in a second, and then figure out which pair of factors is going to break this down appropriately to add up to b. Finally, we rewrite the function in factored form, and then we solve each chunk. So we just saw that we can take two binomials and multiply those together, and if we do that, we usually end up with a quadratic. So the process of solving or factoring a quadratic is going to be kind of like doing this distribution process backwards. You can think about it as undistributing or unfoiling. So let's take a look at this first one here. We've got a function y equals x squared plus 7x plus 12. And then I've rewritten this so that it's set equal to 0. Remember, that's the first step, to set it into standard form and equal to 0. So now I want to think about if I sort of went backwards and I undistributed two distinct factors, what would those numbers be that would get me back to this quadratic? And this is the tricky bit about solving quadratics, is trying to figure out what would this number be here. We have to plus some number, then plus some other number. What would those two numbers be to perfectly add up to 7x and also at the same time multiply to get 12? So I like to think about this with a little X puzzle, and you might have learned the box method in algebra. I'll show you that in a minute as well, just so you can verify what you learned last year if you were in a different class. But I like to use this little X puzzle. So it's really simple. I'm just thinking, what am I going to multiply to get 12 that's at the same time going to add up to get 7? So to think through this, I want to look through all the multiples of 12, all the different ways, factors of 12, all the different ways we can multiply to get 12. So we can do 1 times 12. We can do 2 times 6. We can do 3 times 4. And that's it. Notice how I went through the factors really systematically. 1 times this, 2 times this, 3 times this, until my numbers meet in the middle. And that's usually a good idea. All right, so these are my 3 options. These are the 3 pairs of factors I have. I'm looking for the one that adds up to give me 7. So 3 by 4. All right, so 3 times 4 is going to be my perfect factors that are going to solve this quadratic. I've got x plus 3 and x plus 4. So we can verify that this is the same equation. We could go to Desmos and we could plug this in, and then we can plug this in, and you'll see that those are the exact same parabola. Those are 2 graphs that are exactly the same, just a different way to write it. Standard form, factored form. All right, so the final step of this is to solve each factor. Our goal is to figure out what would x need to be for this to be 0. So the way to do this is really simple, but there's a little bit of finesse to it that we should think about. The reason we're allowed to do this next step is called the zero product property. Basically, it's a simple idea that says, look, we're multiplying these 2 things together, and 0's coming out. That means either this part is 0, or this part is 0, or both. The only way to multiply to get 0 is if you're multiplying by 0. So this next step is going to be where we break this apart and we solve our 2 chunks for 0. All right, so x plus 3 could be equal to 0. That would happen when x is negative 3. Right, this is a simple equation we can solve. X plus 4, this part could be 0. That happens when x is negative 4. So we have our 2 solutions, and we could use Desmos to verify this is where we touch the x-axis. But those are the 2 values of x that solve this equation. We could also take these numbers and plug them back into the original equation and make sure it gives us 0. Negative 3 squared would be 9, plus 7 times negative 3 would be minus 21, plus 12 would be back to 0. All right, so this is how I'd solve these problems. I like to use this little x puzzle. I put the number I need to multiply to get on top, that's c. I put the number I need to add up to get on bottom, that's the b value. And then I figure out what perfect factors can do both at the same time. You may have learned something called the box method in algebra, and it's a great way to think about this as well. Basically, it turns this into a geometry problem. So basically, the area of the box is represented by this equation. We've got x squared, and we've got 12. And then the 7x is going to be split up into 2 pieces. We've got that piece down there and that piece down there. These are going to add up to 7x. This can help us visualize the puzzle and figure out, well, what are the perfect numbers that are going to multiply to get 12 and also add up to 7. So I know that x times x is the squared part. And then we have to kind of think through the same process either way, right? Thinking through the factors of 12, which ones add up to 7. Then we can figure out, oh, if this was 3x and 4x, then that would work. So we'd have x plus 3 and x plus 4 as our 2 factors. It's another way to think through the same process. I don't love the box. I think it's a little time intensive, especially hopefully after we've reviewed this from your first algebra class, we'll start to get really used to this and we won't need that visual anymore. But if you learned it this way and you're comfortable doing that, don't let me stop you. Okay, this is a great way to visualize the problem, but I like to kind of simplify it. So going forward with the examples, I'm just going to use my little X puzzle instead. But feel free to use the box if you like it. Okay, let's try another one, and this time I'm going to try to do a lot less of those tangents, explaining every little detail, and just go through the problem. So you might have been a little overwhelmed by this first one, but let's just go through the process this time. Okay, we're in standard form, and we're already set equal to 0. So I'm going to go ahead and solve this. So again, my goal is to rewrite this into factored form. I'm going to have x, some number, times x some number equal to 0. Now, to figure this out, I've got to figure out what is going to multiply to give me 49 and what is going to add up to 14. This is the way that I like to visualize these problems. So I remember that I have to multiply to get 49, and then I've got to add up to get 14. I call this the X box, the X puzzle. It can help us think through what are these magic numbers, what are these magic factors, go here and here, that are going to help us solve this problem. Cool, so let's think about 49. What are all the different ways we can multiply to get 49? So again, we can kind of think of through all of our factors like we did over here. Well, we can do 1 times 49. Can't do 2 times anything, or 3, or 4, or 5, or 6. But we can do 7 times 7. You can see here that it's really useful to know your multiplication tables really well. Okay, so does 7 and 7 work? Yeah, if I did 7 here and 7 here, we multiply to get 49, and we also add up to get 14. We do x plus 7, x plus 7. All right, so this one's a little different just because both of our factors are the same thing, but that's okay. It just means we're going to have a single answer. So again, once we have this in factored form, we want to solve each of the factors. Since they're the same thing, we don't have to bother really writing them down twice. We'll talk about what it really means to have multiplicity, have to multiple roots that are the same. But for now, we can just see that x equals -7. You might be wondering if you're doing a quadratic, how can you have a single answer when you have this curved shape? So we wanted to take a look at this really quick. We can see that there is actually only one answer at -7, and that's right at the vertex, right at the tip of the parabola, just barely touches the x-axis. Cool, so there's our solution. Circle. Oh. All right, let's do a couple more examples. I've got k squared plus 3k minus 28. Again, I want to rewrite this in factored form. This time we got k instead of x, but it does not matter. Right, just a variable. And I immediately wrote x. All right, we got k and k. So we got to figure out what are the ways we could break down 28 that are going to add up to 3. And notice here that we don't just have 28, we have -28. So let's take a look. We want to multiply, get -28. Multiplying to get to here. At the same time, we want to add up to 3. So we've got to multiply to get -28. So we're going to have one positive and one negative. So the only way to multiply to get a negative is if we have opposite signs. So we're really not adding up to get 3 necessarily, it's more like subtraction, but it still follows. Okay, so let's think through the factors of 28. 1 times 28, 2 times 14, 3 times nothing, 4 times 7, can't do 5, can't do 6, and we're done. All right, so these are our 3 options. Do any of these add up to 3? No. But because this is negative, right, because we're multiplying to get a negative, that means one of our factors is going to be a negative. So we're really looking for which one has a difference of 3. And if we look at 7 and 4, that's going to be our pair. So our 2 factors be 7 and 4, but one of them has to be negative. So look here, we have a +3 when these are combined. If I tried -7 and 4, I had to combine those to get -3. But if I did +7 and -4, then they add up to 3. So that works. So my factors are +7 and -4. And again, the last step on this is to solve each factor. So again, if you like to skip this step when you're writing out your work, that's okay, because I know you can solve this very simple equation in your head, but I want to keep writing it to keep hammering home the idea that what we're doing is applying the zero product property. This idea that says I'm multiplying 2 things together to get 0, then one of them has to be 0, or maybe both of them are 0. That is the logic that allows us to do this. Cool, so we have two answers. K is -7 and K is 4. If we wanted to verify our answers, we could again throw this into Desmos and check and make sure that those are our roots. All right, we've got two last problems here. So I'm going to knock these out for you just so you have a few more examples. Okay, starting out, this one's wrong because we are not set up in standard form. I've got a number over here on the right, and I need that to be set equal to 0 to solve. Right? Otherwise, we can't use that 0 product property. So to start out, I'm just going to add 5 to both sides so that we end up with 0 on the right. Again, we're working with a different variable, m, here instead of x, but who cares? Stand in for an unknown value. Okay, so now we have this in standard form, and I've got to get it factored. My goal is to figure out what multiplies to get 18 that at the same time is going to add up to 9. Cool, so think through our multiples of 18. We could do 1 times 18. We could do 2 times 9. We could do 3 times 6. Can't do 4, can't do 5, and we're back to 6. All right, so for adding up to 9, then 3 and 6 are going to be our magic numbers here. Let's see, 18 is positive, so these can both be positive and add up to 9. That works out beautifully. So we've got m, and our factors are going to be 3 and 6 here, plus 3 plus 6. So this time let's go ahead and skip to the end here. I can see my factors are 3 and 6, so my solutions are going to be m is -3 and m is -6. Again, because we solve each factor for 0. All right, last problem here. This one's a little bit different. We've got n squared is equal to -8n. So this one's different for a number of reasons. We're not set equal to 0, and we don't have any constants. So let's see if we can solve this anyway. So I'm going to add 8n to both sides. All right, again, I still want to set it equal to 0. We can have standard form even if we don't have a constant, even if our constant is 0. All right, we can think of this as plus 0. All right, so it's still in standard form. I'm not going to write plus 0 though, because it's a waste of space. Okay, so we could use the same X puzzle that we've been doing, and this works out actually. We could think of this as we need to multiply to get 0, because 0 is our constant. Remember, plus 0, we could throw that in there. So we're multiplying to get 0, and at the same time adding up to 8. So that means one of our factors is going to be 0. It's the only way to multiply to get 0. And if we're adding up to 8, the other one's got to be 8. Our answers are going to be -8 and 0. But I want to think about this a little bit differently. Again, the X puzzle does work in this situation, but I want you to think a little more critically about what we're doing. Remember, the goal, if we look back at that first problem we did, the goal is to factor, which is another way to think about undistributing. I forgot I erased that stuff. Remember, we distributed all that out and found out we got back to the same equation. So let's think about this as a simple distribution problem. All right, what if I wanted to write this as a set of parentheses with some number out front? All right, so I'd have some numbers in here and some number out front, and I'd be distributing that through. Can we think of a way to rewrite it to look like this? And this is sort of your most basic factoring. So we want to ask, what do these two things have in common? N squared and 8n both contain an n. We can factor out an n. Now let's think about what would be left over. If we took an n out, we'd have an n left. If we took an n out of this, we'd have 8 left. So remember, we're really good at distribution. So if we look back, n times n is n squared, n times 8 is 8n. This is a valid way to rewrite this equation. This is our factored form. just like we did before, we solve each of the two factors for 0. On the left, we just got n equals 0. On the right, we have n plus 8 equals 0, which means n is negative 8. So if we think through our X puzzle, it works the same way. But this really gets down to the big idea of this, which is that we are factoring this quadratic. All right, so hopefully those examples are helpful to get you started. We'll be pushing forward with quadratics next class, looking at some more complicated examples. Thanks, y'all.